Crypto airdrops are one of the hottest ways to bootstrap brand new Web 3.0 communities by retroactively rewarding early adopters of new technology with free cryptocurrency. I mean, imagine just being early to an application, just using it and then getting an airdrop of $10,000 or more. Well, believe it or not, this has happened lots of times. We've seen projects like Uniswap, 1inch, ENS, and a lot more. Bored Ape Yacht Club do the exact same thing. I've personally been the beneficiary of many of these airdrops just for using an application early. There's a complete playbook for doing this, and in this video, I'm gonna give you that playbook and show you how to code a crypto airdrop step by step. Just like some of the top projects out there. I'm going to show you how to create your own cryptocurrency, take a huge snapshot of people you want to airdrop it to, and then actually let them claim their tokens from the airdrop. I'm going to code all this out step by step. So before we get into that, if you're new around here, hey, I'm Gregory, and on this channel, I turn you into a blockchain master. So if that's something that you're interested in, then smash that like button down below for the YouTube algorithm and subscribe to this channel. And if you want to learn how to master blockchain step by step, start to finish, then head on over to dappuniversity.com/bootcamp to get started today. All right, so let's jump into this and look at what we're going to build in this tutorial. So we are going to build a crypto airdrop. All right, so what is this? Well, really an airdrop is just a way where you give people cryptocurrency directly to their wallets without them having to purchase it. That's the whole idea, is you just, sort of magically deliver it from the air. Okay, you airdrop it. So we have seen lots of cryptocurrency airdrops for a very long time. This is not a brand new thing. And they're really popular ways of bootstrapping new crypto assets or new crypto ecosystems by essentially, giving away cryptocurrency for free so that, you can distribute it among many holders, okay? So we've seen a new paradigm for airdrops happen over the past couple of years where many applications will reward users who have, used their applications early, early adopters, with a brand new cryptocurrency that they create to support that application. So really popular examples of this lately have been something like Uniswap. All right, this is one of the most popular applications on top of the Ethereum network, where you can, buy and sell tokens at, directly with the application like this. So, Uniswap launched a token in 2020. And they did it with an airdrop. Okay, so basically they took a snapshot of everybody who had used Uniswap prior to a certain date, and then they let them claim Uni tokens for free just because they had used the application, and then that went on to go create the Uniswap governance model and all that type of stuff. We've seen the same pattern play out for the Ethereum name service. Okay, this is a really popular application. Did basically the same thing recently. 1inch exchange. List goes on and on. So this is a really popular way of distributing new tokens with a really specific model for doing airdrop, and that's exactly what I'm going to show you how to create in this video. Let me draw a diagram on screen of the different parts of exactly what I'm talking about. So essentially, you have your users right here, all right, and these are the early adopters of the applications that are on top of the blockchain. And each of these users has a wallet, and they end up using the application. Okay, let's just say it's Uniswap, for example, because that's a really popular application that helps set the tone for this. So you take everybody who, used Uniswap by a certain date, all right? And then let's say Uniswap wants to launch a new cryptocurrency. They do this with an ERC20 token. This is a different smart contract on top of the Ethereum network, okay? And then they basically take a snapshot of everybody who were these early adopters, and then they essentially add those people to this thing called an airdrop contract, okay? And this airdrop contract, what happens is these users can then go to the contract itself once they've been added to it, and they can claim tokens from this airdrop contract, okay, if they had used Uniswap by a certain date. And then, whenever they interact with this, then when they call the claim tokens function, it will just give them tokens for free. Now, this airdrop model has changed slightly over time because it's not like you're just taking a snapshot of everyone's addresses and then just the tokens automatically come up in their wallet. They actually have to do something to get the tokens. They have to claim them through this airdrop contract. So it's a little bit different from maybe some of the early airdrops in the crypto space, but this is the prevailing way of doing things now, and that's why I want to show you in this video. Now, in order to make this possible, there's a key concept that you have to understand, which is called basically a Merkle tree and a Merkle proof. And we're going to talk about what those are right now. Okay, but the other thing is we're going to create a scenario like this. In this video, we're going to have an application that we let users use, okay? And then we're going to have a new token that we're going to distribute, all right? And then we're going to have this airdrop contract that essentially takes this snapshot of everybody. It generates, everything we need to create a Merkle tree and create that, Merkle proof so that we can take a snapshot of everybody, add it to this airdrop contract, and everybody who's eligible can then go claim their tokens from this contract, and it will distribute, tokens to them based on whatever their usage was. All right, so now let's talk about a really critical concept that you have to understand that's going to basically make this entire process work. So this is something called a Merkle tree. All right, so what is a Merkle tree? Well, basically, it's something in cryptography that lets us store information with hashes in a binary tree that can help us do a lot of things quickly, okay? So Merkle trees are used with many applications inside of blockchain. We use them natively inside of Bitcoin or Ethereum, et cetera, for verifying transactions, okay? But one application is doing these airdrops with a Merkle tree and also a Merkle proof. So let's just see how that works. So essentially a Merkle tree, what it is it's a binary tree. So what that means is you can see that it's a root. You have a root right here, and you have these things called leaves and nodes that make up this tree. It's binary because every time you start at one level, you split it into two levels. So by being two, binary. So you start here and then you have two, and then you go here and you have two. All right. So you have a root, and then you have leaves and children. So how you construct this entire tree is you can see that essentially you have data right here, and then that data can get hashed, okay? And then you can take the hashed data on each sibling element, all right? And then essentially hash it to create a combination at the next level, and so on and so forth until you get to the root of this entire tree. So for example, this is just an abstract example. So if you have data in block 1, data in block 2, you can hash that data, or basically, generate a digest of it to make it smaller, okay? Basically take the data 001, convert it into a hash, which basically a hash means you're just using an encryption algorithm to generate a digest that looks different, okay? And then you see the hash of that, which is here, and then you can take the hash of 002 and then combine them together to get a hash of C and D. And then you combine each of these together to get a hash to always make up this root. And so if you want to see what I mean by that, when I say a hash, so here's a hashing function, all right? And so basically what a hashing function is it lets you take in data and then hash it. So I can put any data, I can say, YouTube, all right? And then if I run it through this hashing function, this is the output. And so it's deterministic. Every time you put in the exact same text, it's going to put out the exact same hash. You can change the hashing algorithm over here. You could use SHA-256. I'm going to use KCAC-256 just for this particular example. You can use MD5, whatever. And so, I could say foobar, right? I could say solidity, and you can see what the output is here. Very similarly, if you go back here and look at the stuff, if I say, data from block 001, I could say 001, all right? And that's what the output is. I'm not saying it's going to be 001, but let's just use that as an example. And then similarly, I can copy this hash, all right? And then basically I can say now 002, all right, that's the hash for 002. That's the hash for 002. All right, I can copy that and then paste it in with 001, all right? And let's just do this as an example. All right, and I combine those together with a comma, then I'm basically taking hashes and then combining them together and making a new hash. And so that's exactly what's happening inside this Merkle tree. So I basically have raw data, I hash to get C and D, and then I take the hashes of both C and D together and hash them together to make A, and then I keep repeating that process to get back here. So that's what the hashes look like, okay? And that's how you keep hashing that information back to get to this root. So at the end of the day, the whole idea here is saving space, so saving data, and then doing things very efficiently. Because even if I put in a ton of data, let's say I copy this over like, a bunch of times, you can see that the hash itself doesn't get any longer, okay? Now, if I just, it's more data if I do 001, right? And that's a longer amount of data. But if I do all that stuff I showed you a second ago, it's still the same amount of data. And so one of the benefits here of Merkle airdrops is basically that you can have all this information inside of this with very little storage. And that's where it's really important on top of a chain like Ethereum, where you don't want to, store, you don't want to put in 1,000 addresses into a smart contract or 100,000 addresses. You just want to store a Merkle tree or the Merkle root, okay? And then basically let people add their addresses to see if they're a part of that. And so let's see we'll see what the application there is and how you can use a Merkle tree. So in this previous example, we used kind of just raw data. All right, you can just see this, it's raw data and you hash it to make this tree, but that gets the basics of how a Merkle tree works. So how does that work with addresses? Well, really what you want to see is what's at the bottom of the tree is all the raw data. So if you want to store some information, a list of information, like this is all the blocks in the blockchain. But what if you can say this is block 1, block 2, block 3, block 4. But what if you want to just have, 1,000 addresses, okay? Well, basically what you do is you'd have each address, on this bottom row here, and then you go through exactly what I was talking about. You would hash each address, okay? You'd run it through a hashing function like this. You could say like, my address is 0x25, whatever, ABC, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And then you get a hash of that address. And then essentially you do that for each address. And then for each pair, so the first and second, and then third and fourth, you'd combine those together and you generate a hash of that, okay? And then you keep repeating that process. It does it with the alphabet here, but you can see what that would look like for addresses. So A, B, C, D, E, F, G, all the way through P. Eventually, you keep going through this 2 by 2 until you get a root of the grouping A through P. It'd be the same thing if you had, 100,000 addresses for your airdrop. You put all 100,000 addresses on the bottom row, and then just 2 by 2, you keep combining together until you finally get this root. That's how you construct the Merkle tree. Now, what about the Merkle proof? So the Merkle proof, essentially, what it does is it lets you prove that, one of these addresses belongs to this tree without having to traverse the entire tree and know exactly what it is. Okay, that's why it's so amazing. In this example, it's showing you the letter H, okay, that's a part of this set A through P, because H is in the alphabet, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. And if you want to prove something with this Merkle root, all you have to do is know the hash of this, okay, as it relates to this. And then essentially what you can do, which with the magic of cryptography, without getting so far deep into how it works, is that you can just prove that this right here belongs to the root that you have constructed through this entire tree without having to know what the entire tree and what every single element is inside of this root. Okay, that's what's really amazing about it. And so essentially, if you just know one address with this Merkle proof, you can prove that the address is contained in this root that gets constructed with all these addresses that you combine together to make up this Merkle tree. And so at the end of the day, what that's going to be able to prove is that you were a user of the application at a certain point, and yet you're eligible for this airdrop. And anytime you call this function on this claiming smart contract that we're going to create in this video, that you can receive the tokens, and we can prove all that mathematically with cryptography, which you're going to see right now. All right, so let's go ahead and start coding out the project. So you'll see a link down in the description below to the final code solution for this particular tutorial. Okay, so inside of here, you're going to see the technology and tools that we're going to use. We're going to use Solidity for writing the smart contracts. We're going to use JavaScript for testing this, because that's how you're going to see the airdrop work. We're going to write a test that that shows all this. This shows this entire scenario and how it works, so that you can implement it in your own applications. We're going to use Ethers.js for blockchain interaction. So whenever we actually perform the airdrop, that's how we're going to do it with Ethers. And we're going to use Hardhat for the smart contract development framework. So you're going to need a couple dependencies installed on your computer to do this. You're going to need Node.js installed and also Hardhat. So you can follow the setup steps inside of here in order to get both of those on your machine. All right, so in order to get started with the code solution, you want to take the URL in the link down below and go to your terminal, and you do git clone and then paste in the URL here. All right, I've already done that step, so I'm going to skip it for now. But you also want to enter into that newly created directory whenever it's finished. So cd erc20 airdrop. Okay, so I'm already inside of this directory, and you can see it here, erc20 airdrop. So the next step is to install all of the dependencies for this specific project inside of here. So you can just do npm install. All right. So this will take a few seconds on your computer here. I've already done this, so it should finish pretty fast. But you should see a success message just like this whenever it's done. Okay. And so now I'm going to open up the code into my text editor. I'm using Sublime Text. You can use whatever text editor you'd like. I'm just going to do this with a shortcut that I have configured here, just double dot. And now you'll see all the code for the project. All right, so let's go ahead and take a quick tour of what we have inside this project. So we have the smart contracts for this entire airdrop in the contracts folder. Okay, we can see we've got this token, which is a cryptocurrency that we're going to use to airdrop. This is an ERC20 token. We've got the actual airdrop implementation, which we'll go over here in a minute. Okay, and then we have this ETH swap contract, which is going to be like the application that the users use in order to receive the airdrop. So let's talk about the scenario that we're creating here. So basically, in terms of the application that people use, we're going to use a tutorial that I've done on my YouTube channel called ETH swap. Okay, where we essentially recreate something like Uniswap, which again, Uniswap's one of the most popular applications on top of Ethereum. They, sort of pioneered this method for retroactively doing an airdrop, or one of the people made it really popular. And so basically, we're going to take this Uniswap-like clone, and then we're going to say that anybody who used this Uniswap clone prior to a certain time is going to receive this airdrop. So if you want to check out the full tutorial for the Uniswap application, you can check out this video. Okay, we'll link it down in the description below. You can also see the code for it here inside of GitHub. Okay, so it's got the full stack, code with the smart contracts and the UI and everything. And then also the full guide here, which you can see over at dappuniversity.com, that explains how this entire application works. Okay, so I'm not going to go through everything on that. But we're going to take that smart contract and say that's the application that we want people to use, and anybody who's used it prior to a certain time is going to receive the airdrop. And so that's what this smart contract is. This is the ETH swap airdrop, which basically has some functions that lets people buy tokens and sell tokens. And anybody who has used this contract to buy tokens or sell tokens before a certain time will be the beneficiary of this airdrop and can claim the tokens. So that's the first smart contract to watch out for. The second smart contract is going to be the token itself. Okay, so this is going to be an ERC20 token. So Ethereum lets you create a cryptocurrency without creating your own blockchain, but with smart contracts with ERC20 tokens. So a token is just a smart contract. It governs the entire behavior of the cryptocurrency, like who owns how many tokens. It lets people buy, transfer tokens from one wallet to another. It lets them, be sold on cryptocurrency exchange and also airdropped. So with ERC20 standard, you don't have to reinvent the wheel on that. We're going to use a library. We're going to use the Open Zeppelin library. Okay, and I've imported the Open Zeppelin contracts for ERC20 inside of here. And we just inherited from that smart contract and basically created a token called, gold token, right? So gold or GLD. And then whenever we put this smart contract in the blockchain, we can basically just say how many tokens we want to create in existence. And then we add the initial supply here. And then we send them to the person who deployed the smart contract, okay? So you can substitute this for whatever ERC20 token you want to. If you want to airdrop your own cryptocurrency, you just use your own ERC20 token in place of this one. But for now, we just created a demo token inside of here. So we got the ETH swap smart contract, which is the application, and then the token smart contract, which is just the cryptocurrency that we're going to airdrop. And then finally, we have the actual airdrop itself. Okay, so we're going to go over this. You're going to see how it works in a second. But basically, this is the smart contract that you're really going to want to pay attention to for this particular tutorial. So we're going to go over how that works. And then we're also going to go through how the airdrop functions, which is going to be inside this test file here. So what we're going to do is just use a test to create a simulation to how the airdrop is going to work. We're going to have all these accounts inside of here that we actually we set up the scenario with code. We basically import all the smart contracts. We deploy the ETH swap contract to the network. We deploy the token contract to the network, and we create a simulation where a bunch of different accounts actually use the airdrop itself. Okay, or sorry, they use the ETH swap app itself, and then we wait a certain period of time, and then we take a snapshot of all those people, and then we add them to the airdrop contract, and then one by one, we go through and show how people who are eligible for the airdrop can claim the tokens, and people who are not eligible for the airdrop will not claim the tokens. And so that's what we're going to focus on the rest of this video, because that's the important part, is actually how to create that airdrop contract, how to put it on the network, how to create the Merkle tree so that you can do a Merkle proof, let people claim tokens that way. And then we'll walk through this setup step inside the test so that you can see each individual part that you need to do and rewrite this test to ensure that your airdrop, works properly. All right, so now let's talk about how to create the actual airdrop itself, because that's what we really want to focus on in this video. Not how to create a token or how to create an application that people can use. So we got plenty of tutorials on how to do that. You can definitely check the ones that I've linked in that previous video. But what we're going to do in this case is basically use a library that's going to help us do this. All right, so we used OpenZeppelin as a library to create the ERC20 token. And, doing these Merkle tree type of examples is also kind of a solved problem. Or, there are solutions out there that you can take off the shelf to make this a lot easier, okay? Because you can get really advanced really quickly on how to do this, if you're going to write it from scratch. But let's just take a good solution off the shelf, which is this OpenZeppelin library here. So they have special cryptography contracts that are going to let us use this Merkle proof. And you can actually see that they have this Merkle proof with these functions that has this verify, where you can verify on chain, who's eligible in this case for the airdrop. So we're going to use this verify function inside of our smart contract, and we're just going to pass in the proof, the root, and the leaf in order to do that. So we're going to use that, and we're also going to use Merkle Tree.js on the client side inside the test so that you can actually generate all the components that you need to pass into this function. Okay, so we're going to use two different libraries, OpenZeppelin and also Merkle Tree.js, and sort of build the bridge from both sides so that we can construct this Merkle tree for this particular airdrop. And you're going to see exactly how that works right now. Now I'm going to clear out this contract and construct it line by line so that you can see exactly how each part works. So like I was saying before, we're going to start with the contract. It's an airdrop. It's going to inherit from the OpenZeppelin ERC20 token. What we want to do is sort of build a bridge from both spots. We want to get to the spot where we can actually call this verify function whenever people claim tokens. But let's talk about the pieces that we need in order to do that. All right, so we need three arguments: the proof, the root, and the leaf. Let's start off with the proof. So the proof is something that we're going to store inside the smart contract whenever we create it. All right, and then we also need to know how many tokens that people can claim whenever they come claim the airdrop. So we're going to create a constructor function that's run once and only once whenever the smart contract is put on the blockchain. So we'll put that here. So constructor, we're going to pass in the root and then also the reward amount. All right. So these would be like settings for the smart contract that will never change. The Merkle root will never change. And then also, because that's going to be, sort of the source of truth or database lookup, all right, for who is eligible for the airdrop. And the reward amount is never going to change because people can always claim the same amount of tokens. So we're going to save those to the top of the file as a state variable. So we'll do a bytes 32, all right, for the Merkle root. All right, this is essentially our database lookup for who's eligible for the airdrop. And bytes 32 is the data type that we want to use here. And then for the reward amount, we want to add that to the top of the file too as a state variable. And this is going to be just a uint 256, just a number of tokens that they can claim. You could make this however many tokens you want to. It could be one token, it could be a million tokens. You just have to figure out your tokenomics design and customize it for whatever you want each individual person to claim. So that's our initial settings. So we have one part of the equation here, which is the root. This is our lookup, right? And now we need to pass in the proof. So let's look how we do that. So we're going to create a function called claim. All right. Now this is the function that people are going to call whenever they come, claim the airdrop. So whenever we do that, we're going to pass in the proof, which we'll construct with Merkle Trees. You'll see that in the test, but let's just say we're going to pass it in the function here. And what we do with that proof essentially is we use the Merkle proof, contract to call this verify function. All right. And so what we're going to do is say that right here. So Merkle proof.verify, and we're going to pass in the proof. That's, pass into the function here. We have the root, all right, which we have in the smart contract already. But now we need the leaf. All right, the leaf's going to be the last part of the equation. So I'm just going to say leaf right here. But what we want to do is essentially construct that leaf, all right? So what we're going to do is basically take the person's address and hash it, and then put that into the function. And you do it like this. All right, you say byte32 leaf equals kcac256. All right, and then you pass in the ABI encoded package or packed address of the person who is calling the smart contract function. So this is just the person who, is calling claim. Okay. Now we have everything that we need in order to verify this. Okay. So we can add some more behavior here in a second, but this is the core functionality. If you had this, you could just basically, process the claim. And whenever we do that, we want to require that this person is eligible. So we're actually going to add a requirement statement. So Solidity, we can say require, and then we can pass in, let's see here, the Merkle proof. And then say, incorrect if they fail. So basically, if they're ineligible, we can say that they're not eligible for the airdrop. So you can write this one line, but I'm just going to break it up into 2 lines. All right, just for formatting, you can see that's what it looks like by itself, but just to make it a little more readable, we're going to do this. All right. And then basically, if they're able to do that, then we mint tokens for them, message.sender. And then we pass in the reward amount. Okay, so we're creating tokens out of thin air so that people can actually claim this. So basically, we're going to say this is how many, this is the reward amount, this is the root, and that's going to determine the maximum supply of tokens that can be claimed in the airdrop. And then essentially when someone calls this claim function, we're going to check that their address is actually part of this with the Merkle proof. And then if they're not a part of it, they're not going to be able to call any more of this function, and they won't mint any tokens. But if they do, if they satisfies, then we will mint them new tokens and they'll get the airdrop. The last thing we want to do is actually keep track of people who have already claimed the airdrop, because we don't want them to claim it twice. So we're going to keep track of that inside of a mapping at the top of the contract like this. So mapping address. We can put in the address and then a Boolean, so true or false, and call it claimed. So basically, we're going to, anytime somebody actually calls this claim function, we're going to say claimed message sender is true. So basically, we're just going to pass in their address to the key of this mapping, and then we're going to set it to true. All right, so every time they call this function, they will say, hey, you've claimed your airdrop. And if they have claimed their airdrop, at the top of the function, we basically want to say require that they have not claimed it. So basically, we look up their address, and if they've claimed it already, it'll say true. And we want to require that it's false that they have not claimed it. And if they have, we'll just stop this function and say already claimed airdrop, and then they can't do it twice. Okay, so that's it. That is an overview of everything that you need inside this file. I'm going to clean up the code a little bit just so that it's in its final form. So, we pull in the airdrop, we pull in the Merkle proof contract. We add our token here. We put all our variables at the top. We put our settings in. We do the constructor, and then we have this claim function that lets people actually claim tokens from the airdrop with the Merkle proof. So now let's look at the other side of the equation of actually simulating this scenario so that we have users who have used the application take a snapshot of their addresses, deploy this contract with the appropriate Merkle root and the reward amount, and then watch people actually be eligible to claim these tokens. All right, so now let's actually go to the test file to see how the airdrop works, okay? So we've got an entire scenario inside of here that's going to, simulate this airdrop. And you can do all this, on chain with your own applications. But let's just clear out the content of the test file here and construct it so that you can see how it works, okay? So I'm going to start off with a blank slate. What I'm going to do is import the important parts of the test at the top of the file. I need to create that from scratch. But we're going to import expect from chai. That's just going to allow us to write the tests. We're going to import ethers from hardhat. That's going to let us, write JavaScript and connect to Ethereum that way. Okay, we're going to import Merkle Tree from Merkle Tree.js. That's what I showed you here. Okay, that's going to help us construct the Merkle Tree so that we can create the proof, all right, that we can put in the smart contract whenever you deploy it. And then we import KCAC256, which is our hashing function that we're going to use inside of here. And then also just a library from ethers called ArrayIfi. Okay. So we're also going to just create some shortcut helpers inside of here. Two-way, that's going to let us convert cryptocurrency to way. And then from way, which is going to let us convert the opposite direction. You'll see how we use those inside of here. Okay. So the first thing that we want to do is set some variables at the top of the file. Okay. So we're going to say tokens in pool. This is basically going to tell us how many tokens that we want to have that are going to be claimable in the airdrop. Okay. So if you look at the numbers here, this is 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. So basically 1 billion tokens. And for, whenever we put this in the smart contract, we want to save this as the way value. So we convert it from tokens to the appropriate decimal places with way. All right. The next amount is the reward amount. So how many tokens we want people to claim. In this case, we have 500 tokens. All right. So we can say 500 tokens, two-way. That's the decimal amount that we need to put in the smart contract. So these are our variables. We're going to have 1 billion tokens and let each person claim 500. The next thing we want to do is actually create a function that's going to set up this entire scenario. So we're going to have this before function. All right. And this before function is what's going to get called whenever we run the test. So basically inside of here, we're going to say, set up the airdrop. All right. And then right here, we're going to have a function that essentially checks the airdrop. All right. And we're basically just going to say, check that the airdrop works. Okay. So it'll be 2 steps. We'll set up the scenario, and then we'll check that the airdrop code actually works. Inside the before function, we're going to set up a scenario where, different development accounts in this case are going to use the application. Okay. So what we're first going to do is basically create an array that shuffles through numbers from 0 through 19. And so basically the elements of the array are going to represent the development account number, and the index is going to represent the order in which the account's going to use ETH swap. So basically we're going to shuffle that through, and we're going to have an order here that says, this person's going to use it, then that person's going to use it, then that person's going to use it. Okay. So that's the first step. And we do this, and we store all that information inside this array. Okay. And so next what we want to do is actually get all the addresses that we're going to shuffle. So this is going to be all the accounts in this scenario. So basically we just say addresses. So this is going to be ethers, get signers. That's how we pull in all the development accounts. We want to store this as a variable on the top of the file as well, so we can access in different parts of the test. We say let address here. Okay. The next thing that we want to do is actually deploy the ETH swap contract, which is the application that people are going to use inside this scenario. So we say ETH swap factory equals await ethers get contract factory ETH swap, and then we pass in the first account in the list, all right, as a deployer. And then we say, ETH swap equals await ETH swap factory deployed. All right. And then next what we do is get the transaction receipt from the deployment. All right. So basically after it's deployed, we get the transaction receipt, and then we get the block number out of that. So why is this important? Well, anytime you put a new smart contract in the blockchain, do a transaction or anything like that, you're going to get a block number. All right. And so we want to reward people who have used the application before a certain block number. So basically, we can take the block number and then say, add a certain amount of blocks to actually, have a cutoff. So anybody who used it before that block is going to get tokens, but anybody who used it after that block is not going to be eligible for tokens. So we can store the block cutoff at the top of the file here, and also the contract block number like this, and say contract block number. We're going to store that we just pulled out of the transaction receipt, and then also get the block number cutoff. So any account that uses eSwap before including this block number are eligible for the airdrop. So this is going to be a cutoff, and basically we're going to take this block number and do some math and say, here's the 11 block difference for, how anybody uses it within that 11 block window is going to be able to be eligible for the airdrop. Now, you could customize this however you want to. You could take the block number your contract deployed and say, 100 blocks, 1,000 blocks, 1,000,000 blocks, whatever it is. You could just change that setting here. So the next thing that we do is actually put the token on the network. So that looks exactly like the other step. We deploy eSwap the same way. We're going to deploy the token that way. All right, we just say, basically this eSwap token, we get the token address, and we get the contract factor, and we attach the token that way. And then we add the expectation that we have the amount of tokens in the pool. Okay, so this token balance of this eSwap address is equal to tokens in pool. Okay, and then now what we want to do is actually have every single account buy tokens in a random order. Okay, so we basically just say promise to all, and then we use that shuffle that we created up here to randomize the accounts, and then we buy the tokens from the application. Basically, we use it, and we just say, hey, we're going to use this many tokens, and then we wait for each one of those to finish, and then we get the block number, and then we expect it equal to index plus 2. Okay, so it worked as expected on the chain. And then next, what we're going to do is actually set up the airdrop contract. So we have deployed the application, we've got the token, we've let all these people randomly use the application. Now we want to construct their eligibility for the Merkle Tree airdrop with Merkle Tree JS. So what we're going to do is basically set up all the information that we need in order to do that. So if you look inside the eSwap smart contract, you're going to notice that anytime somebody buys or sells tokens, we have this event that's emitted. Okay, and basically we're going to say tokens purchased, message sender is going to be the address. Here's the token address, the token amount, and the rate. And so what we're going to do inside of here is basically get all the events of people who called this function. We're going to get the entire event stream for this, and then get all the unique addresses out of here. And that's going to be who we use as the snapshot to prove that they used our application on chain. Okay, so basically we're going to start off with that. We're going to say query all tokens purchased between the contract block number and the block number cutoff. Okay, so we're actually going to filter that out and say that's the event we want to look for. And then we want to filter based on the contract block number and the block number cutoff. So anybody who used it during this specification that we specified here. And then we make sure that this equal to this. Results length is equal to the block number cutoff minus the contract block number. Okay, only that many people did it. And so now we have those addresses. We actually want to construct the Merkle tree and then generate the root that we can put inside the smart contract so that we can inject the proof later. So first of all, what we do is get all eligible addresses from the events and then hash them to get the leaf nodes. All right, so we basically say leaf nodes equals result map, and then we hash them with the kcat 256 hashing function. All right, and then we get the account here. Okay, that's the leaf nodes. And then next we generate the Merkle tree from the leaf nodes. We just say new Merkle tree, this leaf nodes, kcat 256, and then we sort the pairs as true. That's straight out of the documentation from Merkle Tree JS. You can see exactly how they do that here. We basically do the exact same thing inside of our file here. Okay. And then we get the Merkle root hash so that we can put the smart contract in the blockchain. We calculate the root hash just like this Merkle tree get root. And then finally, we deploy the airdrop contracts with all the variables that we need, just like this. So we deploy the airdrop contract, await ethers get contract, factory airdrop address or adder 0 as a deployer. And then we pass in the root hash, which we calculated here through all this construction. And then we pass in the reward amount, which is configured at the top of the file. So now we've successfully set up the entire scenario. We've generated the accounts. We've put the application on the blockchain. We put the token on the blockchain, and we have let them all use the application. We've taken a snapshot who all's eligible, and then now we basically query for all that, and then generate the Merkle tree, and then generate the proof so we can deploy the airdrop contract with all those settings. Now we want to write the test to say that everybody's eligible for the airdrop can actually claim it. So we do that code just like this, all right? So basically we say that every account who is eligible can claim the airdrop. So we just loop through all of them, all right? And we get the proof, all right? So this Merkle tree get hex proof, we hash it, all right, get the address. And then that's the proof that's going to get put into the claim function. And then we get the airdrop contract, all right, and we call the claim function, we connect it. We call the claim function with the proof because that's the only argument that we need here. You can see, you can see this claim function here. We just pass in the proof to see that they're eligible, all right? And then we check the balance, all right? And we make sure that it's the same as the reward amount. And so that should work for every user. And then we check that it fails anytime they try to claim tokens again, all right? And then if they don't have the proof, then basically we reject the transaction and show that it doesn't work. And we can run the test like this. We say npx hard hat test, and we'll watch it work. And boom, there we go. It works. So only eligible accounts should be able to claim the airdrop. All right, so that's an overview of how to create an airdrop with ERC20 tokens with smart contracts directly on the blockchain. So again, this is one of the most popular methods for bootstrapping new cryptocurrencies, distributing them retroactively, rewarding other people for using applications early, becoming early adopters. This is one of the most popular ways people are doing airdrops for, applications like Uniswap, ENS, 1inch Exchange, and lots of other NFT projects as well. You can apply this exact same thing to new NFTs. This is really just scratching the surface on what you can do, and you've seen an exact implementation of that inside this tutorial. So I'm excited to see what you come up with after learning this. You can just go in and change all this for your settings for your own applications. So I hope you like this video. As always, smash that like button down below for the YouTube algorithm. Subscribe to this channel if you haven't already. If you like this tutorial and you want to see more videos like this, you can definitely go to my YouTube homepage. You can find those free courses there. They're like Udemy courses, but they're totally free. And if you like those and you want to take the next step, or hey, maybe you want to take a master shortcut entirely, I can check out my blockchain master step-by-step start to finish over at dappuniversity.com/bootcamp. You don't have to be an expert to get started today. I've helped people with zero coding experience become real-world blockchain developers in a matter of months. So that's all I've got. And until next time, thanks for watching Dapp University.